Hello students, very good morning. Today we are going to take the concept of 10th standard ICSE board, hydrochloric acid HCl. Here HCl is a gas. It is covalently bonded compound. It is a polar in nature. It is highly soluble in water because of polarity. Means due to high electronegativity of chlorine, it will acquire little negative charge, it will acquire positive charge. It has polar compound, not very strong polar like HF, but it is having good polarity. So due to its polar nature, it is soluble in water. Its solubility is near about 450 times, means if 1 ml water you can dissolve 450 ml HCl. So it is very highly soluble in water due to its polar nature. So HCl is a gas and it's having covalent compound because to complete their octet they undergo sharing of electron, and this is the polar covalent bond having bond length 127.4 picometer or 10 raised to the power minus 12 meter. To complete their octet they undergo sharing of electron. In this way a hydrogen form duplet and chlorine form octet. So now we are going to get hydrogen chloride through experiment or lab method of preparation of HCl. Here round bottom flask is there and we put some sodium chloride, it is called rock salt. Now sodium chloride is kept at the lower portion of the round bottom flask, and this is a threshold funnel, and through this threshold funnel some sulfuric acid is poured. Now when sulfuric acid inserted through this and it is collected over here, now what will happen? Sulfuric acid, concentrated sulfuric acid is non-volatile and it is slowly heated. Okay, it is not rapidly heated, very slowly heated, and slowly heated with a gas burner in a round bottom flask. What will happen? When sodium chloride, it is called rock salt, react with concentrated sulfuric acid, this is called king of chemical. At heated, this dial is heated below 200 degrees Celsius, less than 200 degrees Celsius, it forms sodium hydrogen sulfate or sodium bisulfate with liberation of HCl gas. Now here concentrated sulfuric acid is used because concentrated sulfuric acid is non-volatile and it reacts with NaCl and it forms sodium bisulfate. Here sodium bisulfate is a compound which is used as a baking soda and lot of things. I will give you the notes. Now again when concentrated sulfuric acid reheated with sodium chloride above 200 degrees Celsius, it forms sodium sulfate. The sodium sulfate is completely insoluble, hard, and is stick to the wall of the glass tube. And when it is stick to the wall of the glass tube, it can break the glass, it can consume extra fuel. So fuel consumption we can decrease, or we can protect our glass tube by accumulating or stick over the glass tube, and it is a hard solid, and due to this reason we don't heat about 200 degrees Celsius because we want chlorine HCl gas by the reacting sodium chloride with concentrated sulfuric acid. We don't take nitric acid because nitric acid is volatile. Nitric acid is volatile. Sodium chloride react with concentrated nitric acid HNO3 less than 200 degrees Celsius. HCl plus NaNO3 is formed. Here we get HCl, but what happened? It is volatile. Due to its volatile nature, we need to keep less temperature. And one more thing, HCl is volatile and it comes with the along with the HCl, and it is difficult to separate them. So to avoid this problem, we use concentrated sulfuric acid as a reacting substance. Now this HCl will go up because it is lighter, and it will pass through this tube, and it is under the we keep concentrated sulfuric acid as a drying agent. Here it is a, we can say, concentrated sulfuric acid is used as a anhydrating agent because removal of water molecules. Okay, removal of water molecule. If it is acting like an anhydrating dehydrating agent, it will remove water from the compound. Means if C2H5OH remove water, it will form ethylene molecule, including water. This is called dehydrating agent work. Now here sulfuric acid used as a drying agent means when we get the HCl through this moist HCl we get, means it has water content, and this water content HCl inserted in this, and we want to dry it, we will put inside the sulfuric acid. Now sulfuric acid absorb water molecule of moist HCl gas. Now dry HCl gas will move this side. Now dry HCl gas moved this side through this, and here air is present in this, but what will happen? HCl is heavier than air, so HCl gas will go down and air will come up. This is called upward displacement of the air. The upward displacement of the air. So here sodium chloride is heated slowly, and this HCl gas, moisturized, or we can say moist HCl gas having water content, this HCl gas moves up and it will pass inside the concentrated sulfuric acid. Now here concentrated sulfuric acid act as a drying agent, means it will remove the water molecule, it will remove the moisturized portion of HCl. Now the dry HCl gas will pass through this point, and we get, in dry HCl we get pure and dry HCl gas, because the air will come up and downward displacement of HCl and upward displacement of the air molecule, because heavier particle go down and lighter particle go up. So density of HCl or HCl is more heavier than the air, so it will go down and the air go up, and we get now a dry HCl gas at the bottom. Now we want to know whether we get HCl or not. So we can't see because it is a colorless. So we put a glass rod, and which is dipped in ammonia solution. What is ammonia solution? Ammonia solution is the solution of ammonia with water. Ammonia with water, you will get ammonium hydroxide, and this ammonium hydroxide reacts with HCl to form ammonium chloride, which shows the white fumes. Means they will ask you which shows the white fumes or PPT. It shows the white fume. There is a drying agent. This white fumes by NH4Cl. So we come to know that there is a HCl is present, because HCl react with ammonium hydroxide, or we can say ammonia uh, ammonia water, or we can say aqueous ammonia. Aqueous ammonia means NH3 plus NH3 plus water gives ammonium hydroxide. So ammonium ion is there, which is basic in nature. Ammonium ion is there, and OH negative ion that react with HCl to produce water molecule and ammonium chloride, and this ammonium chloride shows the white fumes. So what we came to know? We came to know about the lab method of preparation of HCl. How we will prepare HCl? We have a round bottom flask. We'll heat it slowly. Now here, this is the Thusel funnel, and through this Thachal funnel we will put some sulfuric acid inside it very slowly, gently, and now it is slowly heated. What will happen? It contains sodium chloride, which is called rock salt. This sodium chloride react with concentrated sulfuric acid below 200 degrees Celsius. It form baking soda plus HCl, sodium bicarbonate, sodium bisulfate plus HCl. Now here when we heat above 200 degrees Celsius, it forms sodium sulfate, and this hydrogen will eliminate, and you will get HCl plus washing soda. Now here a concentrated sulfuric acid used as a drying agent. Here the concentrated sulfuric acid used as a reactant. Or now this HCl moves up, and this HCl is a moist HCl. It is having water content. Now this HCl pass into the solution where is a concentrated sulfuric acid is present. It's called drying agent, or we can say dehydrating agent also. But dehydrating agent is a substance which react with substance to eliminate the water molecule from the system. So ethanol react with concentrated sulfuric acid, and heated you will get ethylene molecule and water. Here the sulfuric acid acting as a dehydrating agent. Here this is a drying agent, because whatever the water molecule it will absorb, water molecule, and the pure dry HCl is present. Now here the downward displacement of the HCl or upward displacement of the air, because air is lighter than this, so it will go down, and upward displacement of air you will get the dry HCl. Dip glass rod, which is dipped in ammonia solution, and ammonia solution is what? This is ammonium hydroxide react with HCl to form ammonium chloride plus water. So this is the concept, and here if the nitric acid is used, you will get the mixture of nitric acid and HCl, which is not good, and it is volatile. That's why we don't use nitric acid. This is one more thing. We don't use calcium oxide as a drying agent, because calcium oxide is basic in nature. It is called quicklime also. It is basic in nature. When it react with HCl, it gives calcium chloride plus water. So salt plus water. This is the reaction. Now phosphorus pentoxide react with HCl to form phosphoryl chloride and metaphosphoric acid. So P2O5 when we are using, it react with water molecule of HCl also, and it is also acidic. P2O5 is acidic, but it is weak acid. Now it reacts with HCl to form phosphoryl chloride plus metaphosphoric acid. If we see HCl react with phosphorus pentoxide, it will form phosphoric acid also. First, it will create phosphoric acid, then it will create a metaphosphoric acid also. So these are the reaction done by the phosphorus pentoxide. So P2O5 we don't use, and CaO we don't use as a drying agent. Here the sulfuric acid is used as a drying agent, because sulfuric acid here the sulfuric acid is not going to react with HCl. So we use this. So bye bye students. Have a nice time. God bless you all. Take care.